Hi! We met again, your teacher in Math 9, Mrs. Mitch Biduya. I hope you learned a lot from my previous videos. And now, we are in our third week of the first quarter. The learning competency that you are going to learn, solve equations transformable to quadratic equations, including rational algebraic equations. The code, Math 9, Algebra, first quarter, third week, first lesson. These are the objectives that you are going to attain for this week. First, transform equation into quadratic equation in standard form. Second, solve equations like rational algebraic equation, transformable to quadratic equation. Third, use the best method like factoring quadratic formula and completing the square in solving a quadratic equation. The lesson for this week is all about solving equation transformable to quadratic equation. Throughout this lesson, solving equation transformable to quadratic equation, we can encounter different forms of equations. So, what are these equations? A. Equations that are not written in standard form. B. Rational equations, which solution lead to quadratic equations. Letter C. Equations that are quadratic in form. The part A of the lesson is equations that are not written in standard form. So let us start solving equations that are not written in standard form. Ax squared plus bx plus c equals 0. The equations here are actually quadratic equations. However, we need to transform these equations to standard form. Ax squared plus bx plus c equals 0. In order for us to solve these equations, here are some examples of these equations that are not written in standard form. Number 1, x times the quantity of x plus 10 equals 21. Number 2, the quantity of s minus 8 squared equals negative 15. Number 3, the quantity of t minus 3 squared plus the quantity of t minus 1 squared equals t plus 1. Number 4, the quantity of 2r plus 3 squared minus 3 times the quantity of r minus 2 squared equals 10. Number 5, the quantity of m minus 4 squared minus 6 equals the quantity of 2m minus 1 squared. How do we transform each equation into a quadratic equation? And what mathematics concept or principle do we apply? As you notice, the 5 equations are written in different forms. So, in transforming these equations, we need to examine first each equation to determine the best approach to be used in transforming these equations into a quadratic equation of the form ax squared plus bx plus c equals 0. Together, let us do the first activity. Transform each of the following equation into a quadratic equation in the form ax squared plus bx plus c equals 0. Example number 1. X times the quantity of x plus 10 equals 21. Since the left side of the equation is written in factored form, thus we use the distributive property. So we have x times x equals x squared. X times positive 10 equals positive 10x equals 21. Next, to make the left side of the equation equal to 0, we can use the addition property of equality. So we will add both sides of the equation by a negative 21. Or we can also use subtraction property of equality by subtracting 21 to both sides of the equation. Thus, the equation becomes x squared plus 10x minus 21 equals 0. Hence, the standard form of the equation x times the quantity of x plus 10 equals 21 is x squared plus 10x minus 21 equals 0. Okay, good job! Next is example number 2. The quantity of s minus 8 squared equals negative 15. Since the left side of the equation is a square of a binomial, so we change this to perfect square trinomial. So how do we change this to perfect square trinomial? Yes, that is FOIL method. What do you mean by FOIL? FOIL means first, outer, inner, and last. We multiply first the first terms of each factor. So that is s squared. Next, multiply the outer terms of the expression. That is negative 8s. And multiply the inner terms of the expression. So that is equal to negative 8s. Then, add the two results. So that is equal to negative 16s. Lastly, multiply the last terms of the two factors. So that is equal to 64. Then, equals negative 15. Next, by applying the addition property of equality, adding both sides of the equation by 15, we can make the right side of the equation equal to 0. Next, combine like terms. 64 plus 15 equals 79. So, the equation becomes s squared minus 16s plus 79 equals 0. Hence, the standard form of the quantity of s minus 8 squared equals negative 15 is s squared minus 16s plus 79 equals 0. Good job! In example number 3, the equation has two expressions that are square of a binomial. So we must transform these expressions to perfect square trinomial. The expression, the quantity of t minus 3 squared becomes t squared negative 60 plus 9, and the quantity of t minus 1 squared becomes t squared minus 2t plus 1 equals t plus 1. Please take note to this. The shortcut way to make the right side of the equation equals to 0, we transpose t plus 1 to the right side of the equation. So this makes t plus 1 to negative t minus 1. Again, if we transfer the term to the other side of the equation, we have to change the sign of the term. Next, combine like terms. So, t squared plus t squared minus 60 minus 2t minus t plus 9 plus 1 minus 1 equals 0. This becomes 2t squared minus 9t plus 9 equals 0. Hence, the standard form of the quantity of t minus 3 squared plus the quantity of t minus 1 squared equals t plus 1 is 2t squared minus 9t plus 9 equals 0. Okay, good job! Next, example number 4. The quantity of 2r plus 3 squared minus 3 times the quantity of r minus 2 squared equals 10. Since in the equation there are square of binomials, we will transform these binomials to perfect square trinomial. I'll teach you how to transform square of a binomial to perfect square trinomial in a shortcut way. This is how to do it. So in a perfect square trinomial, there are 3 terms. So to obtain the first term of the trinomial, you are going to multiply the first term of the binomial by itself. Second, to obtain the second term of the trinomial, you are going to multiply the first term and the second term of the binomial. Then, times 2. Next, to obtain the third term of the perfect square trinomial, you are going to multiply the last term of the binomial by itself. So in the expression, the quantity of 2r plus 3 squared, so if we're going to transform this to perfect square trinomial, this becomes 4r squared plus 12r plus 9. Then copy negative 3. Next, to obtain the first term, multiply r times r, that is r squared. Next, to obtain the second term of the trinomial, multiply r times negative 2, r times negative 2, then times 2. So that is negative 4r. Next, to obtain the last term of the trinomial or the third term of the trinomial, we will multiply the last term of the binomial by itself. So negative 2 times negative 2, that is positive 4. So the expression becomes r squared minus 4r plus 4. So remember this, that in a perfect square trinomial, the last term is always positive. Then the sign of the second term of the perfect square trinomial depends on the sign of the given binomial. These two expressions become 4r squared plus 12r plus 9, and the other r squared minus 4r plus 4. Since the equation has negative 3 in the second term, so by distributive property, the expression of the second term becomes negative 3r squared plus 12r minus 12. Then, by transposition method, we have negative 10 equals 0. Next, combine like terms. 4r squared minus 3r squared equals r squared. Next, positive 12r plus 12r equals positive 24r. Next, positive 9 minus 12 minus 10 equals negative 13. Then equate to 0. Hence, the standard form of the equation, the quantity of 2r plus 3 squared minus 3 times the quantity of r minus 2 squared equals 10 is r squared plus 24r minus 13 equals 0. Okay, good job! Example number 5. The quantity of m minus 4 squared minus 6 equals the quantity of 2m minus 1 squared. Since the equation has two expressions that are square of a binomial, we transform this to perfect square trinomial. So the equation becomes m squared minus 8m plus 16 minus 6 equals 4m squared minus 4m plus 1. Next, transpose all the terms in the right side of the equation to the left side. So we have m squared minus 4m squared minus 8m plus 4m plus 16 minus 6 minus 1 equals 0. Then combine like terms, negative 3m squared minus 4m plus 9 equals 0. So the equation becomes negative 3m squared minus 4m plus 9 equals 0. Or multiply negative 1 to the equation to make the leading term positive. So the former equation is also the same as 3m squared plus 4m minus 9 equals 0. Hence, the standard form of the equation, the quantity of m minus 4 squared minus 6 equals the quantity of 2m minus 1 squared is 3m squared plus 4m minus 9 equals 0. Good job! Do you know already how to transform equations that are not written in standard form? Very good! After all, you have the knowledge in transforming equations that are not written in standard form. So, we can now solve quadratic equations that are not written in standard form. This may be solved using any of the 4 methods. So, can you recall the 4 methods? What are the 4 methods of solving quadratic equations? The 4 methods are factoring, extracting square roots, completing the square, and quadratic formula. So, I'll show you some examples in solving equations that are not written in standard form. So, example number 1, let us solve x times the quantity of x minus 5 equals 36. First step, we're going to transform to standard form, since the left side of the equation is written in factored form. Thus, we're going to simplify this expression using the distributive property. So, x times x equals x squared. Next, x times negative 5 equals negative 5x. Second, solve this equation. We use the factoring method in solving this equation, since the equation is factorable. So, we will follow the steps in using the factoring method. So, we will factor x squared minus 5x minus 36 equals 0. The factors of x squared minus 5x minus 36 are the quantity of x minus 9 and the quantity of x plus 4. So, the equation becomes the quantity of x minus 9 times the quantity of x plus 4 equals 0. So, by applying the zero product property, we have x minus 9 equals 0 or x plus 4 equals 0. Then solve x is equal to 9 or x is equal to negative 4. Now, we're going to check if the two values of x can really satisfy the original equation. So, let's substitute negative 4 to x in the original equation. So, negative 4 times the quantity of negative 4 minus 5. Is it equal to 36? Next, negative 4 times negative 9, is it equal to 36? 36 is equal to 36. Okay. So negative 4 satisfies the equation. Next, substitute 9 to x in the original equation. So we have 9 times the quantity of 9 minus 5. Is it equal to 36? Then, 9 times 4, is it equal also to 36? Next, 36 is equal to 36. The value of x, which is 9, satisfies the equation, or the equation is true if the value of x is 9. Therefore, the solutions of x times the quantity of x minus 5 equals 36, or negative 4 and 9. Example number 2, find the roots of the equation. The quantity of x plus 5 squared plus the quantity of x minus 2 squared equals 37. Since the left side of the equation has two terms that are square of a binomial, we can transform this to perfect square trinomial. So the equation becomes x squared plus 10x plus 25 plus x squared minus 4x plus 4 equals 37. Then, group like terms. X squared plus x squared plus 10x minus 4x plus 25 plus 4. And transpose 37 to the left side of the equation. So, it becomes negative 37. This can make the equation equal to 0. Then combine like terms. X squared plus x squared equals 2x squared. Next, 10x minus 4x equals positive 6x. Next, 25 plus 4 minus 37 equals negative 8. Then equal to 0. Reduce the equation by dividing each term of the equation by 2. So the reduced equation is now x squared plus 3x minus 4 equals 0. Now, let us solve the equation by factoring method. The factored equation is now the quantity of x minus 1 times the quantity of x plus 4 equals 0. Then, by applying the zero product property, x minus 1 equals 0, or x plus 4 equals 0. Then solve, x is equal to 1, or x equals negative 4. Thus, the roots or the solutions are x equals 1 and x equals negative 4. Let us now check if positive 1 and negative 4 can really satisfy the original equation. Substitute negative 4 to x in the original equation. So we have the quantity of negative 4 plus 5 squared plus the quantity of negative 4 minus 2 squared. Is it equal to 37? Okay, let us find out. Next, 1 squared plus negative 6 squared. Is it also equal to 37? So 1 plus 36. Is it also equal to 37? Yes, 37 is also equal to 37. Negative 4 can make the equation true. Next, we will substitute 1 to x to the original equation. So we have 1 plus 5 squared plus the quantity of 1 minus 2 squared. Is it equal to 37? Next, 6 squared plus negative 1 squared, is it also equal to 37? Then 36 plus 1, is it equal to 37? Yes, 37 is equal to 37. Therefore, the solution of the equation, the quantity of x plus 5 squared plus the quantity of x minus 2 squared equals 37 or negative 4 and 1. Here are some reminders in solving quadratic equations that are not written in standard form. First, you need to examine first the equation in order to determine the best approach to be used in transforming into quadratic equation. Second, after transforming these equations to quadratic forms, this may be solved using any of the following methods: factoring, extracting square root, completing the square, or quadratic formula. Third, follow the steps of the chosen method and check if the roots can really satisfy the original equation. The second part of the lesson is solving rational equations which solutions lead to quadratic equations. There are another equations that are transformable into quadratic equations. These equations may be given in the form of rational algebraic equations that are not written in standard form. So, we must transform these equations to standard form. However, we will recall the different steps in performing the mathematical operations involving rational algebraic expressions before transforming to standard form and solving the equations. Let us now recall the rational expression. So what is rational expression? Rational expression is a ratio of polynomials which can be in the form of P over Q, where P and Q are polynomial expressions and Q is not equal to 0. And now, let us recall the steps in adding and subtracting rational expressions. So what are the steps in adding and subtracting rational expressions? The steps are: number 1, find the LCM of the denominator. Take note that the smallest number that is a multiple of all the denominators is called the least common denominator, or the LCD. Number 2, set a new rational expressions with a new numerator for each fraction. To obtain it, divide the LCD of each denominator and multiply the result by the numerator of the former expression. And the new denominator is the LCD. This will make the new expression as similar fractions. Number 3, simplify the new expressions by adding or subtracting the numerators and copy the denominator. Here are some examples in adding and subtracting rational expressions. Example number 1. Add 2x over 3 plus the quantity of x plus 1 all over x. The solution is, first, we will get the LCD since we are adding dissimilar fractions. So, what is the LCD? Yes, the LCD is 3x. Now, set the LCD as denominators of the new fractions. This will make the new expressions as similar fractions and equal to the original expressions. To obtain the numerator of the new fraction, divide the LCD by each of the denominator and multiply the result by the numerator of the former fractions. So, 3x divided by 3 is x. Then, multiply to 2x. and 3x divided by x is 3. Then multiply to the quantity of x plus 1. By distributive property, the expressions become 2x squared over 3x and 3x plus 3 over 3x. Next, we are now adding similar fractions. We will combine and arrange the numerator in descending order. The result is now 2x squared plus 3x plus 3 all over 3x. Example number 2, subtract 5 over the quantity of x minus 2 minus 3x over the quantity of x plus 2. What is the LCD? The LCD is equal to the quantity of x minus 2 times the quantity of x plus 2, or equal to x squared minus 4, because the quantity of x minus 2 times the quantity of x plus 2 are factors of the difference of two squares. Again, set the new fraction. The LCD is the denominator. To get for the numerator of each new fraction, divide the LCD by each of the denominator and multiply the result to the former expression. So, x squared minus 4 divided by x minus 2 is x plus 2. Then, multiply this to 5. And divide x squared minus 4 to x plus 2. That is x minus 2. Then multiply this to 3x. By distributive property, the fractions become 5x plus 10 all over x squared minus 4 and 3x squared plus 6x all over x squared minus 4. To combine the numerators, we will distribute first the numerator of the second fraction. So, we have 5x plus 10 minus 3x squared minus 6x all over x squared minus 4. We can now combine the terms of the numerator. So, the result is negative 3x squared minus x plus 10 all over x squared minus 4. How did we find the sum or the difference of rational algebraic expressions? By following the steps in adding and subtracting rational expressions. How did we simplify the rational expressions? In simplifying rational expressions, we do the same way that numeric fractions are simplified. What mathematics concepts or principles did we apply in adding or subtracting rational algebraic expressions? We're dealing with the least common denominator, rules in adding and subtracting similar and dissimilar fractions. Let us now transform rational algebraic equations into quadratic equation in the form ax squared plus bx plus c equals 0. Transform each of the following rational equations into a quadratic equation in the form ax squared plus bx plus c equals 0. Number 1, x plus 5 over x equals negative 6. Number 2, 2x over x plus 4 equals 3 over x minus 1. Number 3, x plus 2 over x plus 1 equals 1. Number 4, 3 times the quantity of x over x plus 1 squared plus 7 times the quantity of x over x plus 1 minus 6 equals 0. Number 5, 1 over x squared minus 3 over x plus 2 equals 0. How do we transform each rational equation into the form ax squared plus bx plus c equals 0? So let's start equation 1. X plus 5 over x equals negative 6. So what is the LCD? Yes, it is x. Now we will divide the LCD by each of the denominator and multiply the result by the numerator. So we have x times the quantity of x plus 1 times 5 all over x equals negative 6. Then, by distributive property, the expression becomes x squared plus 5 all over x equals negative 6. Then, cross-multiply the result or x squared plus 5 and equal to negative 6x. The standard form of x plus 5 over x equals negative 6 is x squared plus 6x plus 5 equals 0. Example number 2, 2x over x plus 4 equals 3 over x minus 1. To transform this equation, we can use two methods. The first solution, we will be using the cross multiplication property. So we have 2x times the quantity of x minus 1 equals 3 times the quantity of x plus 4. So by distributive property, the equation is 2x squared minus 2x equals 3x plus 12. Let's transpose the terms in the right side to the left side of the equation. So, 2x squared minus 3x minus 2x minus 12 equals 0. Next, 2x squared. Then, combine like terms. Minus 5x minus 12 equals 0. The standard form of 2x over x plus 4 equals 3 over x minus 1 is 2x squared minus 5x minus 12 equals 0. Next is solution number 2. In this method, we will be using multiplication property of equality. We multiply the LCM to both sides of the equation. So what is the LCM? Yes, the LCM is the quantity x plus 4 times the quantity x minus 1. We have the quantity of x plus 4 times the quantity x minus 1 times the quantity 2x over x plus 4 equals 3 over x minus 1. So this is simplified to 2x times quantity of x minus 1 equals 3 times quantity of x plus 4. Then, by distributive property, it becomes 2x squared minus 2x equals 3x plus 12. And by transposition method, we have 2x squared minus 3x minus 2x minus 12 equals 0. Then, combine like terms. Negative 3x minus 2x equals negative 5x. Next, negative 12 equals 0. So, the standard form of 2x over x plus 4 equals 3 over x minus 1 is 2x squared minus 5x minus 12 equals 0. So, based on the two solutions, we come up with the same answer. Therefore, in transforming equations like equation number 2, we can use multiplication property of equality, or it can be cross multiplication property. Next, example number 3. X plus 2 over x plus 1 equals 1. So, what is the LCM? The LCM is x plus 1. Very good. By multiplication property of equality, we have x times the quantity x plus 1 plus 2 equals x plus 1. By distributive property, x times x equals x squared. X times 1 equals positive x. Next, plus 2 equals x plus 1. So, x squared plus x. By transposition method, we have negative x, negative 1 plus 2 equals 0. Combine like terms, we have x squared plus 1 equals 0. So, the standard form of x plus 2 over x plus 1 equals 1 is x squared plus 1 equals 0. Example number 4. For equation 3 times the quantity x over x plus 1 squared plus 7 times the quantity of x over x plus 1 minus 6 equals 0. So, what is the LCM? The LCM is the quantity of x plus 1 times the quantity x plus 1, or equal to the quantity x plus 1 squared. So, that is equal to x squared plus 2x plus 1. Then multiply both sides of the equation by the quantity x plus 1 times the quantity x plus 1. So, this becomes 3x squared plus 7x times the quantity x plus 1 minus 6 times the quantity x squared plus 2x plus 1 equals 0. We have 3x squared plus 7x squared plus 7x minus 6x squared minus 12x minus 6 equals 0. Arrange the terms in descending order. 3x squared plus 7x squared minus 6x squared minus 12x plus 7x minus 6 equals 0. Combine like terms. 4x squared minus 5x minus 6 equals 0. So the standard form is 4x squared minus 5x minus 6 equals 0. Example number 5. 1 over x squared minus 3 over x plus 2 equals 0. So what is the LCM? Yes, that is x squared. So by multiplication property of equality, multiply both sides of the equation by x squared. The new equation becomes 1 negative 3x plus 2x squared equals 0. Arrange the terms in descending order. So the standard form is 2x squared minus 3x plus 1 equals 0. It is now easy for you to solve rational algebraic equations transformable to quadratic equations because you have already acquired the knowledge in transforming rational equations. Before solving the rational equations, we need to follow the steps in solving rational algebraic equations transformable to quadratic equations. So what are the steps in solving rational algebraic equation? So the steps are, first, multiply both sides of the equation by the least common multiple or LCM of all the denominators. Second, write the resulting quadratic equation in standard form. Third, find the roots of the resulting equation using any of the methods of solving quadratic equations. Fourth, check if the solution or solutions can really satisfy the original equation. Example number 1. 6 over x plus x minus 3 over 4 equals 2. So here is the solution. What is the LCM of the expressions 6 over x, x minus 3 over 4, and 2? Yes, the LCM is 4x. We multiply both sides of the equation by the least common denominator, or the LCM. The equation now becomes 24. Why it is 24? Because we will multiply 4x times 6 over x. So that is equal to 24. Because x divided by x is equal to 1. Plus x squared minus 3x. We multiplied 4x to x minus 3 over 4. 4 divided by 4 is 1. X times the quantity x minus 3, that is x squared minus 3x. Next, we multiply 2 times 4x, that is equal to 8x. Next, we write the resulting equation to standard form. So the standard form is x squared minus 11x plus 24 equals 0. In solving the quadratic equation, we use the factoring method. So this becomes the quantity x minus 3 times the quantity x minus 8 equals 0. So by applying the zero product property, we have two linear equations. So x minus 3 equals 0 or x minus 8 equals 0. Let us solve the resulting linear equations. So x equals 3 and x equals 8. The values of x are 3 and 8. So we will check if the two values of x can really satisfy the equation or they can make the equation true. Let's substitute first 3 to x to the original equation. So we have 6 over 3 plus 3 minus 3 over 4. Is it equal to 2? 2 plus 0 over 4. Is it equal to 2? 2 plus 0. Is it equal to 2? 2 is equal to 2. So, 2 is equal to 2. How about when x is equal to 8? Is 8 can make the equation true? Okay, let's find out. 6 over 8 plus 8 minus 3 over 4. Is it equal to 2? 6 over 8 plus 5 over 4. Is it equal to 2? 6 plus 10 over 8. Is it equal to 2? Yes, 2 is equal to 2. Since the two values of x satisfy the equation, therefore, the solutions of 6 over x plus x minus 3 over 4 equals 2, or 3 and 8. Example number 2. What is the LCM? Yes, the LCM is x minus 2. By multiplication property of equality, the equation is now x minus 2 times x plus 8 over x minus 2 equals x minus 2 times 1 plus 4x over x minus 2. Then simplify. We have x squared minus 2x plus 8 equals x minus 2 plus 4x. Or x squared minus 2x plus 8 equals 5x minus 2. Then arrange the terms in decreasing order. So we have x squared minus 2x plus 4x minus 5x plus 8 plus 2 equals 0. The standard form of x plus 8 over x minus 2 equals 1 plus 4x over x minus 2 is x squared minus 7x plus 10 equals 0. In solving this quadratic equation, we have two values of x. X is equal to 5 or x is equal to 2. So by factoring method, or you can also use quadratic formula or completing the square in solving this equation. Let us now check if the two values of x satisfy the equation. Let's start. For x is equal to 5, the equation now 5 plus 8 over 5 minus 2, is it equal to 1 plus 4 times 5 over 5 minus 2? Next, simplify. So we are adding fractions in both sides of the equation. So, first fraction, 15 plus 8 over 3. Is it equal to 3 plus 20 over 3, which is the other fraction? Next, 23 over 3. Is it equal to 23 over 3? Yes, they are equal. Next, let's find out the next value of x, which is 2. So, for x is equal to 2, we substitute to the original equation. So, 2 plus 8 over 2 minus 2, is it equal to
1 plus 4 times 2 over 2 minus 2. 2 plus 8 over 0. Is it equal to 1 plus 8 over 0? Observe that at x is equal to 2, the value of the expression 8 over x minus 2 is undefined or does not exist. The same with the expression 4x over x minus 2. Hence, when x is equal to 2, 2 is an extraneous root or solution of the equation. What is an extraneous root or solution? An extraneous root or solution is a solution of an equation derived from an original equation. However, it is not a solution of the original equation. Therefore, the solution that can make the equation x plus 8 over x minus 2 equals 1 plus 4x over x minus 2 true is 5. Here are some reminders. In solving equation involving rational expressions, transform first the equation to standard form by multiplying both sides of the equation by the least common denominator or LCD, or simplify the left side and right side of the equation, then cross multiply. Then check the solutions by substituting to the original equation. This is because the solution that is obtained may be true to the raised equation, but not to the original equation. The third part of the lesson is solving equations that are quadratic in form. So what are some equations that are quadratic in form? Examples of these equations that are quadratic in form are: number 1, the quantity x plus 3 squared plus 5 times the quantity x plus 3 plus 6 equals 0. Number 2, y to the 4th minus 8y squared plus 16 equals 0. Number 3, x squared plus 36 over x squared minus 13 equals 0. Some equations here are not exactly quadratic, but can either be made to look or generate quadratic equations. How do we solve these equations using the concept of solving quadratic equations? When an equation can be written in the form au squared plus bu plus c equals 0, with u as an algebraic expression, it is said to be quadratic in form and is solved by any of the methods you have already learned. These are the steps in solving equation in quadratic form. Number 1, determine the substitution to be used. Number 2, make the substitution and solve the resulting equation. Number 3, resubstitute the expression from step 1 and solve for the original variable. Number 4, check your answer if necessary. Example number 1. The quantity x plus 3 squared plus 5 times quantity x plus 3 plus 6 equals 0. This equation is a quadratic equation, but it is not written in standard form. Ex squared plus bx plus c equals 0. So in solving this equation, we don't need to transform this to standard form. Why? Because this is written in the form of au squared plus bu plus c equals 0, with u as x plus 3. So I will show you now the solution. So let u equals x plus 3. By doing substitution, we can solve for u. We have u squared plus 5u plus 6 equals 0. By factoring method, we will factor u squared plus 5u plus 6 equals 0. So we have quantity of u plus 3 times quantity u plus 2 equals 0. By applying the zero product property, we have u plus 3 equals 0 or u plus 2 equals 0. Then solve the two linear equation. So we have u equals negative 3 or u equals negative 2. So we already solved the value of u. So we can now solve the value of x. Since the original equation was in terms of x, therefore, we must solve for x. So we will recall our substitution u equals x plus 3. We substitute negative 3 to u. So the equation becomes x plus 3 equals negative 3. Then x equals negative 6. Next, we substitute negative 2 to u. So the equation becomes x plus 3 equals negative 2. Then x equals negative 5. We check if the values of x can really satisfy the original equation, or we must check our answer for extraneous roots. So we go to the original equation and check them there. So here is the checking. Fx is equal to negative 6. By substitution, we have the quantity negative 6 plus 3 squared plus 5 times the quantity negative 6 plus 3 plus 6. Is it equal to 0? Next, negative 3 squared plus 5 times negative 3 plus 6. Is it equal to 0? 9 minus 15 plus 6. Is it equal to 0? 0 is equal to 0. Fx is equal to negative 5. So by substitution, we have negative 5 plus 3 squared plus 5 times quantity of negative 5 plus 3 plus 6. Is it equal to 0? So negative 2 squared plus 5 times negative 2 plus 6. Is it equal to 0? 4 minus 10 plus 6. Is it equal to 0? 0 is equal to 0. Therefore, the solutions of the quantity x plus 3 squared plus 5 times the quantity x plus 3 plus 6 equals 0 or negative 6 and negative 5. Example number 2. In solving y to the fourth minus 8y squared plus 16 equals 0, the way to visualize this is by using the properties of exponents. So we could see it as y squared raised to the power of 2 minus 8y squared plus 16 equals 0. So we make a substitution, let u equals y squared. Then by substituting this into the equation above, we get u squared minus 8u plus 16 equals 0. So this equation is already a quadratic in form. So we can solve this by extracting square root. So we get the quantity u minus 4 squared equals 0. Square root both sides of the equation to eliminate the radical symbol. So u minus 4 equals 0. Then solve the resulting equation. U equals 4. Now we can solve for y. To solve for y, we substitute u to 4. So the equation y squared equals 4. Then by extracting square root, we have y squared equals 4. Y equals positive negative 2. Now we check if y is equal to 2. The equation y to the 4th minus 8y squared plus 16 equals 0. 2 to the 4th minus 8 times 2 squared plus 16. Is it equal to 0? Then 2 raised to the power of 4 minus 8 times 4 plus 16. Is it equal to 0? 16 minus 32 plus 16. Is it equal to 0? Yes, 0 is equal to 0. Next, if y is negative 2, let's substitute negative 2 to y. The equation 2 to the 4th minus 8 minus 2 squared plus 16, is it equal to 0? 16 minus 8 times 4 plus 16, is it equal to 0? 16 minus 32 plus 16, is it equal to 0? Yes, 0 is equal to 0. Therefore, the solutions are 2 and negative 2. Both are of multiplicity 2 since the original equation is a degree of 4. Example number 3, x squared plus 36 over x squared minus 13 equals 0. The equation involves rational algebraic expression. To solve this, we make substitution. So let t equals x squared. So we get t plus 36 over t minus 13 equals 0. To solve for t, we apply the multiplication property of equality because the equation involves rational algebraic expression. However, we need to determine first the LCM. So what is the LCM of the expression t plus 36 over t minus 13? Yes, that is t. We get t times the quantity of t plus 36 over t minus 13 equals 0. T squared plus 36 minus 13t equals 0. Then, t squared minus 13t plus 36 equals 0. By factoring, the factored form is the quantity of t minus 9 times the quantity t minus 4 equals 0. By applying the zero product property, so we have two linear equations, t minus 9 equals 0. That is equal to t equals 9. Or t minus 4 equals 0. T equals 4. To solve for x, let's do substitution. X squared equals t. 9 to t. So by extracting square root, x equals positive negative 3. Or we substitute 4 to t. So we have x squared equals 4. So by extracting square root, x is equal to positive negative 2. So we will check when x is equal to 2. So 2 squared plus 36 over 2 squared minus 13. Is it equal to 0? 4 plus 36 over 4 minus 13 equals, is it equal to 0? 4 plus 9 minus 13, is it equal to 0? 13 minus 13 is equal to 0 because 0 is equal to 0. Next, we will check when x is equal to negative 2. So negative 2 squared plus 36 over negative 2 squared minus 13. Is it equal to 0? 4 plus 36 over 4 minus 13. Is it equal to 0? 4 plus 9 minus 13. Is it equal to 0? 13 minus 13 is equal to 0 because 0 is equal to 0. Next, check when x is equal to 3. So 3 squared plus 36 over 3 squared minus 13. Is it equal to 0? 9 plus 36 over 9 minus 13. Is it equal to 0? So 9 plus 4 minus 13. Is it equal to 0? 13 minus 13 is equal to 0 because 0 is equal to 0. Next, check when x is equal to negative 3. So negative 3 squared plus 36 over negative 3 squared minus 13. Is it equal to 0? So 9 plus 36 over 9 minus 13. Is it equal to 0? Next, 9 plus 4 minus 13. Is it equal to 0? So 13 minus 13 is equals to 0. Therefore, the solutions of x squared plus 36 over x squared minus 13 equals 0 are positive negative 2 and positive negative 3. Here are some important points to remember. Number 1. In solving equations that are not written in standard form, we need to examine first the equations in order to determine best method to be used in transforming to quadratic forms. After transforming these equations to quadratic forms, this may be solved using any of the following method: factoring, extracting square root, completing the square, or quadratic formula. Second, in solving equations involving rational expressions, we must transform first the equation to standard form by multiplying both sides of the equation by the least common denominator or LCD, or use another way. We need to check the solutions against the original equation. This is because the solution that is obtained may be true to the raised equation, but not to the original equation. Third, when an equation can be written in the form AU squared plus BU plus C equals 0, with U as an algebraic expression, it is said to be quadratic in form and is solved by any of the methods we have already learned. So these are the steps in solving an equation in quadratic form. First, determine the substitution to be used. Second, make the substitution and solve the resulting equation. Third, resubstitute the expression from step 1 and solve for the original variable. Fourth, check your answer if necessary. It is best to always check the solutions of the equations. There may be extraneous solutions that may arise while solving them. This is the end of our lesson for the third week of the first quarter. If you have questions, you can ask your math teacher. Stay tuned for my next video. Thank you, God bless, and stay safe. Bye-bye!